all, welcome to Docker Basics to Brilliance course. My name is Kastro Kiran. In the last video, we have understood what is meant by application architecture, and we have also seen what is the difference between a monolithic architecture and microservice-based architecture. In this video, we are going to talk about three important concepts in order to understand the Docker. Firstly, we'll be talking about what is meant by virtualization and what is meant by containerization. And we'll also see the differences between the virtualization and containerization at a plain level. And then we'll be talking about what is the need for Docker and why it is important to understand the Docker in the DevOps culture. And finally, we'll be talking about how Docker has made changes before it has arrived and after it has arrived into the IT industry, especially with the point of view of DevOps engineering. So these are the three concepts that we are going to discuss in this particular video. So firstly, let us understand the containerization and virtualization. Before talking about the virtualization concept, we need to understand the concept that is there before virtualization came into picture. That concept is known as bare metal concept. Now, what is meant by a bare metal concept? In bare metal, we have the hardware components. Hardware components include RAM, ROM, the processor, all these things comes under the hardware components. And on top of hardware components, what will be there is we'll be having the operating system. That operating system is known as host operating system. Now, on top of host operating system, we are going to install the different applications that are required for us in order to work with the applications. That's called as a bare metal server. As an example for bare metal, we can consider our laptop as a bare metal. If you take our laptop or the desktop, our laptop will be consisting of the hardware components such as keyboard, mouse, and also the RAM, ROM, the processor. All these things comes under the hardware components. Now, once your laptop consists of all the required hardware components, then we are going to install the operating system. Now, in our laptops, let's say we have the Windows operating system. In Mac laptops, we'll be having the Mac operating system. So that operating system is called as the host operating system. Now, once you have the operating system, we can install the games, we can install the MS Office, we can install multiple applications, whatever that is required. That's called as the bare metal server, or it is also called as bare metal. This is the first thing that was there before virtualization came into the picture, a bare metal. Now, this bare metal has got advanced into a next level concept, which is known as virtualization. This virtualization concept has come into the picture once we got the concept of the cloud technology. So let's see how this virtualization is going to make the changes between the bare metal and the virtualization concept. Again, in the virtualization also, we'll be having the bottom layer as the hardware components. So we will have all the required hardware components in the virtualization as well. And on top of the hardware components, we will be having the host operating system. Just like how the bare metal is having the hardware and host operating system, virtualization will also have the hardware and host operating system. Now here in the virtualization, we are not going to directly install our applications on the host operating system. So what we will do is here in the virtualization, we will be having another layer, which is known as hypervisor layer. Now, what is the use of this hypervisor layer? By using this hypervisor, we can create the multiple EC2 instances or multiple virtual machines or virtual servers can be created. So that's the importance of hypervisor. Now, each virtual machine, let's say this is my first virtual machine, and I also have the second virtual machine. Now, in each virtual machine, what I will do is I will install an operating system, and that operating system, I'm going to call it as guest operating system. On top of guest operating system, I am going to install whatever applications that are required for me. That's the concept of virtualization. Similarly, in the second virtual machine also, we will be having the guest operating system. On top of guest operating system, we will be installing another application. Along with the application, we can also install the database components as well. So this is how the virtualization will work in the real-time scenarios. Virtualization is something that we actually see whenever we launch the instances in the AWS cloud or any of the clouds that are available for us. So whenever we are launching an EC2 instances, especially in the AWS cloud, we are launching the EC2 instances on top of this hypervisor software. Hypervisor is a software which is used to launch the virtual machines on top of host operating system. Let's say the host operating system consists of the Windows-based operating system. Now, what we will do is we will install the hypervisor software. Once we install the hypervisor software on top of host operating system, we will create the virtual servers, and those are called as virtual machines. So here currently I have two virtual machines, virtual machine 1 and virtual machine 2. On top of each virtual machine, again I will install a different operating system. Let's say host operating system is having the Windows operating system. Guest operating system need not be Windows. It can be Windows also, but let's say I need Linux-based operating system. Yes, it is possible to work with the Linux-based operating system in the virtual machines. This is the concept of virtualization. And as an advanced concept of virtualization, we have got a new concept which is known as containerization. This is where actually Docker will come into picture. Now, before talking about Docker, it is very much important to understand the containerization concept. In the containerization also, we will be having the hardware component. We will also have the host operating system. These two are very much common in all the three scenarios, that is in bare metal, virtualization, and containerization. Now, in the containerization, on top of a host operating system, what we are going to have is we are going to have a container engine. This container engine is also called as Docker engine. So we'll be installing the Docker software here, right? Once after container engine is created, on top of container engine, what we will do is we are going to create the containers. Okay, we are going to create the containers. Let's say this is my first container, which I am calling it as a container 1. And this is my second container. And inside the container, what I will be doing is I'll be installing the applications and its related files. Okay, applications and its related files like the binaries, libraries, all the application related data I am going to install in the containers. That's how containerization concept will work. So to keep it in a nutshell, containerization is the packaging together of software code with all its necessary components, such as the libraries, frameworks, dependencies, so that they are isolated in their own container. Now, each container will have its own application and its own application related files as well. So that's the importance of working with containerization. So in order to work with the containerization concept, we will be taking the help of a Docker in the real-time scenarios. In detail, we'll be understanding the containerization concept in the next video, along with the fundamentals of Docker as well. In this video, my intention is to give you an idea about a brief overview on the bare metal server, virtualization, and the containerization concept. Once this concept is clear, it will be very easy for you to understand on a large scale the containerization concept and how Docker has come into the picture with the help of containers. So this is about the virtualization and containerization concepts. Now let's understand what is the need for Docker. So we have been talking about Docker is something that is going to help us in order to simplify the concepts. So how it is going to help us? Let's understand this particular concept with a scenario. The scenario is, let's say the developers are available. For a project, there will be multiple developers that are available. So what is the duty of these developers? The duty of the developers is to write the code which is required for the application. Now, once the developers has written the complete code, they are going to keep the code in the GitHub repository. Okay, they are going to keep the code in the GitHub repository. Now, from here, as a DevOps engineer, we are going to work. So what we will do from this stage is most important. Now, currently, the code is available in the GitHub repository. Now, the next scenario comes in this way. Let's say you are developing an application, or the developers are developing an application called Hotstar application or Disney Plus Hotstar application. Now, in the first case, what will happen? Developers will be available. Now, what developers will do? Developers will write the code for the application. Now, once developers writes the code for the application, they have to test that code, whether the code is working in a proper way or not. Now, in order to test the code for the developers, they need an environment. That environment we are going to create. As a DevOps engineer, we are going to create that environment. So let's say developer one is using an environment which is having the Tomcat server, okay, which is having the Tomcat server. Similarly, there is another person who is going to do the testing for the application code. Now, for the testing of the application code, testing team will also need another environment where again the Tomcat will be installed. And there will be another team which will be coming into picture, which is known as a production team. Production team also needs another type of environment where they can test the code of the functionality and also whether the code is working fine or not. So this is how the different environments that comes into picture when we are talking about deploying an application. It's not that once the code is developed, directly we are not going to keep the application code as a live environment. So it has to pass through the different environments such as the dev environment, SIT environment, UAT environment, client environment, pre-production environment, or pilot environment, prod environment. Like this, it has to go through different layers of environments. Now, the question here is, who creates these environments? This is the first question. And the second question is, who is going to deploy the code into these environments? None of the teams are going to deploy the code into the environment. Development team has the duty to just write the code and to test the code. That's the only duty of development team. Similarly, the testing team and the production team. So here, who creates these environments is, as a DevOps engineer, we are going to create these environments. And who is going to deploy the code into these environments? As a DevOps engineer, we need to deploy the code into all these environments. Now, in order to do the deployments, we are going to use the Jenkins pipeline. We are going to use the Kubernetes cluster. We are going to create the Docker images, Docker containers. All these things will be done by the DevOps engineer point of view only. So that's where the need for DevOps engineer is actually going to arise. What is the need here? Let's say each team is having each type of environment. So development team is having a dev environment. Testing team is having a testing environment. Production team is having a production environment. Now, in each environment, it's not just only Tomcat server should be available. Along with Tomcat server, they might also need a Java-based code or Java application, and then they might also need certain kind of dependencies. So there will be multiple softwares that will be involved in the process of creating an environment. Now, let's say developer is using the Tomcat 9 version, and the testing team is using Tomcat 7 version. Production team is using Tomcat 8 version. Now, when different versions of the softwares are being used, what will happen? The code functionality will get different. Okay, there will be a chance that the code will not work. In development system, the code might be working, but when it is sent to the testing team is using a different set of applications or the different set of packages. So there is a chance that in testing environment, the application might not run proper. Now, for these, what are the drawbacks of this one? The drawbacks is loss of time and effort is going to take place because we need to install the different softwares in all of these environments. So here I have just taken the example of Tomcat server, but in real time, it's not just only Tomcat web server that will be available. We need to install Java, we need to install the dependencies, we need to install multiple other softwares, making sure that they are all having the same version. Each environment is having the same version. By any chance, if the versions of the softwares gets differ from one environment to another environment, the code functionality will get different. That's another drawback. So there could be version mismatch in the different environments. That's the need for Docker that is actually going to come here. So here I'm just telling that the drawbacks of this kind of working environment. Now, how Docker is going to help us further? Docker will prepare all these environments that are required in order to run our application. Okay, Docker is going to do all these things for us. Again, it will not do on its own. We have to do some configuration. Once we do the configuration, everything will be perfectly fine. And then we can deploy our application in any environment that is available in the real-time scenarios. Now here, Docker is called as PaaS type. What does it mean by that? Platform as a service. We are going to use Docker as a platform in order to deploy the application or in order to package the application in the form of containers. So this Docker is going to use the OS level virtualization. What does it mean by OS level virtualization? We will be talking about that in the upcoming sessions. So first, let us understand the actual need for Docker that is going to come here. Let us understand how Docker is going to help us in order to containerize any type of application. Now, currently, let's say that for any application, we will be having three layers. What are they? The first one is known as a front-end component. The second one is known as backend component, and the third one is known as a database, which we have discussed in the last video. So if you have not watched the previous video, I would recommend you to watch that previous video and then watch the concept, whatever I'm discussing from now on. Now, let's say developers are going to write the code. Once the project development is completed, okay, once the project development is completed, developers are going to keep the code or are going to store the code into the GitHub repository. Okay, into the GitHub repository. This we know. So every developer, once they started writing the code and once they completed writing the code, they are going to keep the code in the GitHub repository. Now, as a DevOps engineer, okay, as a DevOps engineer, what we have to do is we need to deploy this application code. Okay, we need to deploy this application code into multiple virtual machines or multiple virtual servers or virtual machines, you can say. So let me call it as virtual machines because we are using the cloud environment for that. Now, these virtual machines, okay, these virtual machines are called as environments. Okay, these virtual machines are called as environment. Now, as I was mentioning earlier, for each team, there will be a different environment. So what we have to do as a DevOps engineer, we need to deploy the application code which is developed by the developers into the different virtual machines. Why different virtual machines? Because for a project, we will be having the different teams, like the development team, testing team, the UAT team. Like this, we'll be having different teams. So for each team, there will be a setup of environment. And that concept is called as environments. Okay, so what we have to do as a DevOps engineer, we need to deploy the code into all the environments that are available for our project. Let's say that developers have stored the code into the GitHub repository. And as a DevOps engineer, we need to take that code and deploy that code into multiple environments which are available for our application. Let's see what are the different environments that are available in a real-time scenario for our application. Environments for application. Okay, environments for application. In real time, we will be having the different environments. Here on a large scale, I am going to keep a couple of environments. Let's say for developers, what type of environment will be available? So for developers, we will be having an environment which is called as dev environment. Okay, developers will be working on an environment which is called as dev environment. And for SIT, okay, and for SIT, what does it mean by SIT? System integration testing. So to perform the system integration testing of the application, we will be having one more environment, which is known as SIT environment. And for clients, they will also be having an environment, which is known as UAT environment. What is the full form of UAT? User acceptance testing. So that's the UAT environment, which is available for the client. And then for pre-production or for pilot, we will be having an environment. Okay, pre-production testing, we will be having an environment which is known as pilot environment. And finally, we will be having the production release. Okay, for production release, we will be having an environment which is known as prod environment or production environment. So these are the different types of environments that are available in the real-time scenarios for any application. There will be some other environments also, but on a large scale, we'll be having these types of environments. Once the production is successful, then we are going to live. Okay, finally, we will make the application to go into the live environment. What does it mean by live? Live is nothing but where users or the end users will be able to see the application and they will be able to access the application. Now here, what does it mean by environment? Environment is nothing but a server. Okay, environment means a virtual machine, or environment is nothing but a virtual machine. So we are going to create the virtual machines in the cloud environments, right? It can be AWS cloud, it can be Microsoft Azure, it can be GCP, whatever it is. All these things are called as environments. Okay, environment. Now in dev environment, let's say that the developers are using a different versions of software. Okay, let me take an example. So let's say in dev environment, the developers are using the Linux based operating system. Okay, Linux based operating system. And then they are using the Java 11 version of the software. And they are using certain dependencies which are called as Spring Boot dependency. And they are also using a database called MySQL database. So these are the different versions of the software that are being used in the dev environment. Similarly, there are another environments where we have to install all the softwares that are required in order to run the application in all the environments. So as a DevOps engineer, we have to install all the required applications and its application related softwares into all the environments. Now, what is the challenging thing here? For a DevOps engineer, the challenging thing is deploying the application into all these environments. This is basically a troublesome work for the DevOps engineers. Now, let's say if the version of the software gets changed in each environment. In dev environment, I am using Java 11 version. In SIT environment, let's say the testing team is using Java 8 version. In production environment, the production team is using Java 22 version. Now, when the versions of the software gets changed from environment to environment, then it becomes very much challenging for the DevOps engineers to deploy the application. Why it becomes challenging? Because the versions of the softwares are getting changed. In one version of the software, the application might get properly configured, but in another versions of the software, the application might not get configured in a successful way. So when the configurations are different in each environment, it is not that easy to run our application. Okay, it is not that easy to run our application. So in this case, we need one common platform. Okay, in this case, we need one common platform. So when the configurations, okay, when the configurations are different in each environment, okay, when the configurations are different in each environment, it is not easy, okay, it is not easy to deploy our application or deploy or run. To run our application, okay, it is not that easy to run our application. So in this case, okay, in this case, we need one common platform where we can run our application. Okay, where we can run our application. And that common platform is known as the Docker software. Okay, that common platform is known as a Docker software. So in real time, whatever project we should be deployed into multiple environments for different testing purposes, we will be having all these types of environments. So dev environment will be used by developers in order to perform the integration testing. SIT environment is used by the testing team in order to test the functionality of the application or code functionality of the application. And UAT environment is used by the client, which is used to again test the functionality of the application from the client side. And pilot environment is something that is used for pre-production testing. And finally, for production environment, we'll be using the production environment for production release of the application. This is where we are going to finally deliver the project. Now, the thing here is deploying the application into these many environments is a difficult task. Why it is a difficult task? Because of the software configuration might get differ in each of these environments. So to avoid this, we have the concept which is known as Docker. Okay, to avoid this, we have the concept which is known as a Docker. So what Docker will do, Docker will prepare, okay, Docker will prepare the environments, okay, Docker will prepare the environments, Docker will prepare the environments that are required, okay, that are required to run our applications, whatever application it is. In order to run our application, Docker is going to prepare the environment. Now, what is the advantage of working with Docker? Docker will prepare the environment in such a way that the versions of the different softwares will be same in any type of environment. It will not change the versions of the software. It will be maintaining the common versions of the software in all the environments. Once the application is developed by the developers, it will be working in a proper way in all the other environment types as well. So that's the concept of, or that's the need for Docker. So Docker is going to prepare all the environments which are required to run our application in an efficient way without creating any problems. So Docker is basically a PaaS type. What does it mean by PaaS type? Platform as a service. Okay, Docker is actually a platform as a service that uses OS level virtualization. Okay, OS level virtualization. What does it mean by OS level virtualization? We'll be seeing that in the next video. But currently, we will just understand the need for Docker here. Okay, so here, this is where the need for Docker is actually coming into picture. So to keep it in a nutshell, virtualization is nothing but in one operating system that's called as host operating system, we can install the multiple operating systems. How we are going to install multiple operating systems? By using a software called hypervisor software. Okay, by using hypervisor software, we can install the different guest operating systems on the top of the host operating system. Let's say if we install 2 guest operating systems in one host operating system, the performance of the system will obviously get slowed down. Let's say you have your laptop. In your laptop, you have been installing the different software. Now, at one point, when the laptop reaches its exceeding limit or the threshold limits, the laptop will start functioning in a slower way. It won't function that fast. So the same thing happens even with the virtualization concept also. So to overcome that, we'll be using the Docker concept. Okay, to overcome that, we'll be using the Docker concept. That is what we have seen in the differences between the bare metal, virtualization, and the containerization. I hope you now got an idea about virtualization, containerization, and bare metal, and what is the need for Docker. Actually, we did not talk anything related to the Docker. I have just said what is the need for Docker and how Docker is going to play a role in the concept of the DevOps institute. Now, let's see how the scenario was there before Docker has emerged into the IT industry. So to explain this, let me take a scenario here. Let's say a developer is there and he wants to develop an application called Netflix application. Now, whenever developer wants to develop an application, developers will be writing the code for the application. Once the code is written by the developers, then the code will be written by using the different softwares such as Java programming language, Node.js, Spring dependency, Spring Boot dependency. Like this, multiple versions of the softwares will be used of different categories in order to develop the application code. Once the application code is completely developed, then developer is going to test the code in their personal laptops or in their wherever developers has written the code, they will test the code in the developer's PC. Now, once developers feels that the code is successfully running in their laptop, what developers will do? Developers will give the code to another team, which is known as a testing team. Now, what testing team people will do? Testing team people will again test the code. But when they are testing the code might work in a proper way and the code might not work. What is the problem here? The problem is in the developer PC, they will be having, let's assume that Java 11 software is available in the developer laptop. Node.js version is different. Spring version is different. Now, in the testing laptop or in the testing team laptop, they will be having Java 8 version of the software. So what is happening here? The configuration of softwares between the development team and the testing team is different. Now, obviously, when the configurations of the softwares are getting different, the code which is successfully running in the developer laptop will not be running successfully in the testing laptop. So here is the problem that actually comes in the real-time scenarios. Now here, what is the problem? The problem is the compatibility issues of the code. The same code which is running in the developer system might not be running in the testing system. So that's called as code compatibility issues. So this is the usual scenario that was there before Docker has emerged into the IT industry. Now let us understand why we actually need Docker to solve the problem of code compatibility issues. Let's say we have employed the Docker in our project development process. Developer is available. Developer is going to use the Docker concept, and he is going to create a Docker image. This Docker image consists of all the application related information. Now, this Docker image will be shared with the rest of the teams that are available for the project, such as testing team. Now, the same Docker image which is tested in the development team will also be tested in the testing team also, or in the testing team laptop also. And hence, the code functionality issues can be resolved by using the concept of the Docker images. I'll be showing you in detail about how we are going to create the Docker images, how we are going to test the Docker images, and code compatibility issues also we are going to see in the practical cases from the fourth lecture onwards. In the next lecture, I am going to focus purely on containerization concept and evolution of containers also. Once that is done, in the next video, that is in the fourth video, we'll be talking about a practical understanding about all these Docker principles. All the concepts, whatever we are discussing in this video and in the last video, and also in the next video, they will act as a fundamental concepts in order to work with the Docker. So without understanding these concepts, if we directly jump into the Docker concept, it will not be helpful. And in the interviews also, if somebody asks you this background development of the Docker, you should be in a position to talk about all these scenarios here. Now, the code compatibility issues can be solved by using the Docker images and Docker containers concept. So this is all about the virtualization, containerization, and why we actually need Docker in the real-time scenarios. In the next video, we are going to talk about containerization concept and also how the containers has got evoluted over a period of time from the physical servers to the containerization concept. Thank you.